Okay. Quiet, please. All right, so last week we kind of took a break from introducing a lot of new features of Java to focus a little bit more on how you write algorithms. And this week too, we're not so much introducing a lot of new features as sort of trying to develop skills, programming skills. And in particular, we want to look more at testing and debugging because they're so important. And how you can go about setting up automatic testing to make life easier when you're developing and modifying programs. And one of the main things to think about, if you're writing programs, especially commercially writing programs that are going to be used by lots of people and potentially be maintained by people other than yourself, you've always got to be writing, as the last point says, for maintainability, meaning you're not only trying to write good code, you're trying to write it in such a way that it's easy to test it when somebody modifies it, and easy to debug it when errors are found. So let's have a look at an example of some fairly subtle errors that can creep into code. I want you to spend just a minute or so looking at that and see if you can tell me, syntactically that program is correct. It will compile, but see if you can tell me what the output. So there are two print statements here. See if you can think what are the outputs going to be from each of these statements. So what does the program do, and what's the output going to be? So I'll just give you a minute to think about it. And look for details. You've got to look very, very carefully at details. So who can tell me what the program is supposed to do? And note I said, what is the program supposed to do, not what does it actually do? Anybody? Random choice? You? No idea even what it's supposed to do? Well, what's this? What's this thing in the middle? Sum is assigned sum plus 1. What does it do? Okay, so this is inside a loop. Yep. It's supposed to just count up 0 to 4, adding 1 to sum, right? Is that clear? So all it's going to do, all it should do, is start with sum equal to 1, loop around 5 times, and adding 1 to sum. So what should be the result at the end? If you start with 1 and you loop around 5 times, what would you expect the result to be? What? Somebody said 4. Who can't count? 5? 6. You start with 1, you loop around 5 times, add 1 to it, you should get 6. And at the end, double result. What do you think should be the output from double result? Should be. Okay, so let's look at what happens. Okay, so this is just, it could be 5. 6 is probably what we think it is. There are various alternatives. The actual result from that program is 2 from the first statement and 22 from the second. And that's because there are some very subtle logical errors in the code that make it not do what you expected. So let's have another look at this. Stare at that again and see if you can tell me why it doesn't do what you think it should. And it's really just a matter of 1 or 2 characters being misused or out of place. Yep. Well, okay, so down here, what is the type of that expression? We talked about this, I think, last week. If you have, so here we've got a string type, right, plus two numeric types. But if you do a string plus number, what does Java do to the number? Right, it turns it into a string. So what we're actually doing with this second one is, with the double result, is saying turn sum into a string. So it's, in other words, it's the digit 2. And it can, so plus means what when you're talking about strings? Not addition, but what? Right, you're concatenating strings. So this is the concatenation of the string double result colon space with the digit 2 and the digit 2 again. Right? So that's why we get 22 as the result of that one. But why does sum only end up being 2, not 6? Yep. Right. So this is where you've got to be really, really careful. This is a really easy typo to make. You know, you're so used to putting a semicolon at the end of a line that you just say, okay, put a semicolon at the end of everyone. But what does that mean? If I have a semicolon after that circled semicolon, what does that actually mean? Right, that means that there's an empty statement after that for expression. So that loop going around 5 times, it'll go around 5 times doing nothing. Right? So then you fall through to this line, and so sum is still 1. Nothing's happened. So when we do this, sum becomes 2, and that's why we get the output that we get, right? And just following up with those other ones. So it's really easy to write a program that you just, if on first glance, looks logically correct. But there are really quite subtle things that you've made, just simple mistakes that you've made that can screw it up. And you've got to be, so we want to talk about how you're going to find these things and test these things. These are simple logical errors. There are bigger logical errors that you can have, like, you just totally have the algorithm wrong, even though it compiles. Okay? So the kinds of errors you've got to deal with are syntax errors are relatively straightforward because the compiler will catch them for you. And other development environments like, so BlueJ is a fairly simple development environment for Java. More complex ones like Eclipse and NetBeans, if you start typing something that's syntactically incorrect, on the fly it'll start to tell you, did you really mean this? So syntax errors these days can be caught fairly easily by compilers and the development environments. But just because your program compiles does not mean it's correct. Because you could have logical errors, and the compiler can't find these. All it does is compile the code that you've given it. If it's syntactically correct, it'll compile it, but when it runs, it'll do the wrong thing because your logic is wrong. So the errors that we just looked at in the previous program sort of fall into this second category. That they're bugs that you should be able to find fairly easily because they have an immediate effect on the code, like that semicolon in the wrong place. There are other ones that are a lot worse. You can have a logical error. Suppose you're building up a database system. You could have a program that's putting stuff in the database, and everything seems to be okay, but there might be some subtle error that's putting the wrong sort of stuff in the database, and you only find out about it when you start trying to retrieve things from the database. Okay, so the detection of the error is a long way away from the original occurrence of the error. And those are the toughest ones to find. Right? And unfortunately, almost all software that you use, because it's so complex, has errors in it. Now, you know that. You know you're using your favorite operating system and it does something totally screwy. Or you're using your word processor and you think you're putting a picture in one place and it ends up somewhere else. These are all errors that were done, that were introduced during software development, or what's worse, you decide to create a new version of your program, update it, fix another bug, and in the process of doing that, you introduce new errors. And that happens all the time. And if you become programmers, commercial programmers, or you do any kind of programming in real life, you're always going to have deadlines. You're going to have to deliver a product on a certain day. Otherwise, you or your company start incurring late penalties. You have to start paying back money that the client gave you. So you have to deliver on time. So if there's a rush at the end, almost always, the software is never what you hoped it would be, at least not initially. Okay, so how do we try to minimize the errors we get? There are two phases we're going to go through. One is during the development, you want to have a good set of tests that every time you make changes to your code, you can rerun these tests and be sure that the output or the program does what you wanted it to do. Okay? When we were marking your assignments, whether it was the information systems or the design one, what we did was we set up a set of tests. We said, this is what your program should do. So we call your program and we expect this to be the output, and we compare the expected output with your output, and if you got what was expected, then you got the performance mark for that test. And if there's a mismatch between what we expected and what you output, then you lose marks. Okay? That happens in your assignment. In real life, you're going to have a customer ringing up complaining that your program was doing the wrong thing. But what you can do is just the same way as we set up the assignment testing, you should do that for yourself and test what you expect to be the output of the program with what actually happens. So that sort of prevention is the testing phase. The maintenance part is more the debugging. Once the program is actually in place and doing stuff, and someone discovers an error, you've got to sort of do the detective work to trace back and figure out what's going wrong. Okay, we'll skip over some of this stuff. So Malcolm talked a little bit about unit testing, didn't he? Hands up who remembers what unit testing is. Yeah, I know he actually did talk about it. You did talk about these things, like when you're testing a program, the things that you test are, first of all, a fairly typical sort of condition, and then you test boundaries. What happens when you're an extreme case of whatever it is you're trying to do? He did talk about that, didn't he? I'm sure he did. Okay. What we'll go straight to an example in BlueJ. This is an example from the book in chapter 6. And we're going to go through the code, try to understand what it's supposed to do, and then we're going to see how you can construct unit tests. So unit tests mean that one of the advantages of doing object-oriented programming is that you can modularize your code. You encapsulate everything that has to be done to a particular object, whether it's, like in this case, we're going to construct a diary system where we've got appointments and we've got a list of appointments for the day, and if we wanted to extend it, we could have an object that represented a week or a month or so on. Okay? So we first identify the objects that we want to deal with in this, whatever the world is that we're trying to model. We write our methods that manipulate those objects, and remember, one of the principles is that you try to confine the manipulation of an object to the methods that are contained within that class, right? So one of the advantages of doing that sort of modularization is that you should be able to test individual classes and the methods within those classes separately from all the rest of the code. And that means that if you can have confidence in the individual bits then when you put them all together, it should be easier to test and run the whole thing. Okay, so unit testing, just the unit means testing individual pieces of code instead of trying to test the whole thing all at once. And what we want to look at today is how do you do that sort of unit testing? And there are some tools in Java and in BlueJ helps as well to make that sort of testing easier. Okay, so let's first of all, let's create a new day. So a day in this program is an object that will contain appointments. And the day, so when we say new day and give it a day number, it's the days in the year. So I don't know what today is, but let's say it's the 200th day in 2011. Okay, so we create a day object. To create an appointment, let's say this has two parameters. The first one is a description of what the appointment is, and the second one is how long the appointment's for. So let's give it a shorter name. Point 1. We'll say it's the Java lecture, and its duration is an hour. Okay, so we've got an appointment object, we've got this day, and now I'm going to invoke another method in the day that says, well, have a look at that. Can you read that? Is that legible? No? Okay. That's a method called make an appointment, and it has two parameters. One is the time that you want the appointment to be set for, and what's the second parameter? For anybody who can read it, what's the second parameter? It's an appointment object, right? So here, I'm going to say, let's suppose it's our 12 o'clock lecture. And @1 was the name of the object that we gave for that first appointment. So what I'm doing now is creating a new appointment to be attached to the day. And what does that tell us? Sorry? No. That's returning true. So the make appointment returns a Boolean type, and it returns true if it's succeeded in making the appointment and false otherwise. Right? So a case where you would want it to return false is if you did try to do a double booking. Right? If you already had something at 12 o'clock and you tried to do a second appointment at 12, it should return false in that case. Okay, so there's another method defined already in day that says show the appointments for the day. And so on day 200, currently we just have one appointment, which is the lecture at 12 o'clock. Okay? Let's make a couple of others, another appointment. We'll make this one a computing lab. Duration 2 hours. And we'll add that to our day. So this time we'll make it 10 o'clock. And for 2 hours. Whoops, that's right. So that succeeded too. All right, so here, now when I say show appointments, why have I got this comp lab appearing twice there, you think? Right, because I made it a 2 hour duration. I've got it filling two slots. So if you look at this, you can start to understand that the way that the day is represented is by an array of 1 hour slots. And if I have an appointment that is more than 1 hour, I just fill in all of the slots that it belongs to. Okay? So now I've got an appointment at 10 o'clock for 2 hours. I've got an appointment at 12 for 1 hour. Let's have a look at another another method. Suppose I have another thing I want to put in there. Let's say it's a design studio for 3 hours. And I want to know, when is the first 3 hour slot available? You know, I might try to find the earliest one, but I can't do it at 9 o'clock. So when's the earliest that I could do it? At 1 o'clock, with 1300 hours. So I want, so this find a space method. Hang on, it's going to look for an appointment. So let me create my third appointment. Whoops. Which I'll call Design Lab, and we'll make it 3 hours. Now I want to find out, is there space for, where is the first space for this third appointment, which is our 3 hour Design Lab? And it returns, now this hasn't made the appointment yet, but what it's done is told me that the first slot that will fit this is at 1 p.m., 1300 hours, okay? So all that method has done is gone through my array, given the appointment, knowing it's 3 hours long, it's trying to find enough space in that array that it can fill it in. So now that I know that I can fit it in at 1300, I can now make my appointment with that time. So the time is 1300, app 3. That succeeded. So if I now show all of my appointments, I've now got my Design Lab in the right place. Okay? So all we're doing here, all I wanted to do here was show you the basic functionality of what you expect how you expect this program to behave. The next thing that we're going to look at is, okay, suppose we're going through writing this code. I mean, this has been done for you already, but suppose you were writing this code and you want to test it. You want to make sure that it's doing all the right things you expect under all circumstances. And if you make any revisions, we do what's called regression testing. So we have a suite of tests, and every time you make a change to the code, you want to rerun these tests to make sure that the change you've made hasn't broken anything else. And believe me, that happens really often. You fix one bug, and if it's complex code, you don't realize that the thing that you've done to fix it has screwed up something else somewhere else in the code. And unless you're doing this continuous regression testing, you may not have realized for a long time that what you did over here affected this thing somewhere else. So this idea of regression testing is very important. Okay, so Java has a set of there's a set of public libraries available for Java to do this kind of unit testing and regression testing. And BlueJ has a nice interface to that to allow you to construct tests really easily. So the first thing you've got to do is, okay, this is already turned on. When you're running BlueJ, normally you won't see any of the testing stuff. This is normally what you see when you're running BlueJ. If you want to do any of the testing stuff, you've got to find the preferences, go under miscellaneous, and turn on the show unit testing tools thing. Okay. Now there's a different on the Mac. The convention is the preferences go under the app menu there. On Windows or Linux, there are no conventions for where preferences go. But normally, and in the case of Windows and Linux, in the case of BlueJ, it'll be under the Tools menu. Right? So if you're in any of the information systems labs, it'll be there. If you're doing Windows, it'll be there. If you're using Linux, it'll also be there. If it's on the Mac, it'll be under there. Right? The dialog looks pretty much the same. It's still under miscellaneous. So go to miscellaneous, and it'll be there. Okay, so this shows a few additional buttons on the left there that will help you do the testing. Back here, we've got a class that's been created, and it's specifically a test class attached to the day. Right? So the terminology here is that the test class, the reference class for the test is the day. If we have a look at that, there are a couple of methods here, and well, tell me what the methods do. So let's have a look at the first one. Test make 3 appointments. Well, the name's fairly indicative. But tell me on the inside of it, what does it do? And just read off one statement after the other. You. Yep, first one. No, it's just read statement. So we're looking at test make 3 appointments. Just read statement after statement for me. What's the first thing that we do? Black shirt, yep.
First one, so you make an appointment, Java lecture. The second one, you make a Java class appointment. Third one, you meet John.
Yeah, well, hang on, what was the very first thing that you missed?
Day one.
Okay, first of all, you create the day object. Then we're going through creating all these appointment objects. The most interesting ones of these ones are the last 3 statements there. This assert equals method is a method that's provided by the testing environment. And it says that so the first 4 statements up there have just created a bunch of objects. They've created the day object. They've created 3 appointments just like I did. But the interesting bits, the thing that's actually doing the testing, are the last 3 things up there. Because the second argument is saying, in day 1, make an appointment at 9 o'clock using the first appointment we created. And it's going to return a value. Right, so this thing here, this here is an expression, right? It's a method call to the object day 1, and that returns a value. Remember when we added an appointment to a day, remember that it's a method that returned true or false. It returned true if it succeeded in putting the appointment into the diary, and it should return false if it fails to put it in. Right? So if we call that method as an argument to this other method, so remember you can have nested calls. A method call just returns a value, just the same as 1 plus 2 is an expression that returns the value 3. A method call is an expression that returns a value, and in this case it'll be true or false. Okay? So this assert equals says if this method call returns false, right, if it's equal, if these 2 things are equal, then that test succeeded. So that's the way that all of these work. you're calling a method, you have the expected result, which in this case is all Booleans, and you're comparing them. So this assertion is saying if this is equal, then your test succeeds, otherwise that test fails. So in the top we're testing, making 3 appointments and adding them all in, and we expect all of these things to succeed. This second test is checking what happens if I do a double booking. Right? So we've created 2 appointments, both an hour long, and here I add the appointment to the diary at 9 o'clock, and I expect this one to succeed because nothing else is there. The second time, I also try to put this appointment at 9 o'clock, but because there's already one there, I expect this one to return false, right? So my assertion says, first time through this should work. Second time through when I call make appointment, this one should fail. Right? I want it to fail. Right? So I want the result to be false. Right? So when you're doing your testing, you can start out by creating tests that will check when things are sort of going properly, just as a sanity check to make sure that at least roughly your program is doing the right thing. But one of the principles of testing your program is you want to try to make it break. Right? So when you're testing the program, you should be trying not to give it nice input that will check when it works. You should be deliberately trying to make your own code fail. Right? Which is painful, right? Because you dig up all these errors and you have to fix them. But the principle of testing is try to make your code fail. So find all the cases where you think you might have trouble and check it. So the first one is sort of benign test. It's what it should do normally. The second one is when you start thinking, think up all the cases where you might have trouble and sort of poke the code. And if it doesn't work, then you know you have to try to fix it. Okay, so when we call run tests, when we click on this on the side, what it's done is taken the tests are in this test class, run them, and in this case here, the code is correct, so both of our tests succeed. Okay? And what we'd want to do here is add a whole lot more tests as well to try to poke all the other things that could fail on it. And like I said, when we were doing the testing on your assignments, we were effectively doing this sort of thing. Creating a whole bunch of different classes. And the early tests that we did were assuming that everything was fairly straightforward. And just to give you marks for having done basically the right thing. And then the later tests were saying, have you picked up some of these subtleties? Have you made, have you understood all the things that might go wrong and checked for all of those things? So we would tend then to make the later tests a lot tougher. And so, I mean, that's what we do for the assignment testing, but it's what you should be doing in testing your own code, whether it's for assignments or when you end up doing sort of serious programming. Okay. So let's look at how we construct these tests. When you've set the preference to show the unit testing stuff, all these buttons appear, but also some new things appear on the pop-up menu. So you see here with appointment, I'm going to create a new test class. And what that does is it automatically creates a new class that's associated with appointment. And it's got a few things already set up for you. a few methods already set up. Don't worry about that extends bit for the moment. Next week we'll start talking about what we call inheritance, and we'll explain what that part means. But essentially it's saying that, so this junit.framework.test case is a library class for doing the testing, and the code in here is going to use the stuff from this library. So that's basically what the extend is telling us here. And it's created for us some dummy methods. The first is an empty constructor, which isn't going to do anything for us in this case. And these two things. So setup is a method that will do, let's see. I created a whole bunch of objects here and appointments. Suppose I want to now take those objects and use those in my test cases. Right? So before you start doing any of the testing of the methods, the first thing we did was create a bunch of objects. And suppose that these are objects that I'm going to be regularly using in all of my test cases. So the first thing that I want to do before every test is create a bunch of objects and then run my tests on them. And let's say it's the same objects we're going to use over and over again. So there is a pop-up here that says, take the objects that I've created in this bench. You know, the terminology in BlueJ is this is the bench, the object bench. So suppose I want to take these and put them into my tests. So what you see here is that it's now filled up this method called setup with all the calls that I did, all the method calls that I did to create the objects that are currently in the bench. Right, you see that? That I created the day first of all, I created a new appointment, added it to the day, and it just literally recorded everything I did and transferred it into this method. Okay, so there isn't an easy way of writing code because you don't actually have to write any Java. All you do is call the methods that you want, create the objects that you want, and then BlueJ will be very nice for you and it'll just put it all into the code and you'll be able to use it. Okay? Suppose we wanted now to use some of this stuff. Like now I want to create a test. So there's create a test method. And we'll just call it test 1. And you see here that this is a bit like doing audio recording. This red light has gone on, and that means that anything that you do, any method calls that you make now through the BlueJ IDE are going to be recorded as tests. Right? So if we try to make another appointment, say, or add an appointment, let's suppose we try to add appointment 3 twice. What should happen? Right, if I do make appointment at 1300 with appointment 3, this is an appointment I've already made before, right? Correct? So what should the output of make appointment be? False, okay. So this is saying that it actually does return false. But more importantly, what I'm saying here is that whatever the value is that it returns, it should be compared against this value that I typed in. Right, so I want the thing to be actually false. and we'll end the recording for now. So now it's just created a new method for me in this test class called test1. It did exactly, in here it does exactly what I did. In other words, it calls make appointment and adds the same appointment in at 1300. And it tells me that the result of that test should be false. Okay? So it's created this test for me automatically. I mean, just by recording what I did. All right, so what you're going to do when you're writing your code next time is, as you write it, you should be thinking, what do I want this method to return, or how should I want this method to behave? And you go through exactly this process to construct a set of tests that for each method you're going to run not just one test like this, but think of all the different circumstances, like depending on what parameters are passed to this method, what should the output be? So you think through all the cases that you want to test, and you do this sort of run through, and I mean, you should be doing this testing anyway, but because BlueJ allows you to record these tests, you can capture them in the test class and rerun these tests whenever you like, without having to do it all over again. Right? Now, let's have a look at the internals of day. Oh, okay. Bit of revision. Public, static, final, int. What does that mean? What do all those keywords tell us? Public, that's obvious, that this variable is visible from outside the class. Did Malcolm say what does static mean? Okay, so the static keyword means that this variable is attached to the class, not to instances of the class. All right, so we have the definition of day. And normally what you do is you say create a new day object, which is an instance of the class day. And when you have, normally your variables belong to the instance day, right? Just to that object. And so anything you change inside that object is local to there. If you declare either a variable or a method to be static, it means that that belongs to the actual class. Right? It's a variable that can be seen by all the instances of that class, or can be used by that. So where we're saying here is that that variable start of day, so that's saying that we'll assume that the day starts at 9 a.m. And we want this variable to be declared and available to all objects in that class and be visible outside the class. What does final mean? You come across that yet? Yeah, so final means that effectively is declared to be a constant, that you're not allowed to assign a new value to that. Once you've set it up to have the value 9, that's it, doesn't change. So the final is used when you want to have a constant, a number that's never going to change, and you're going to use, so here we're defining the start of the day to be at 9 o'clock, and in the next line we're defining the final appointment to be no later, it'll be 5 p.m., 1700. Okay? And the same thing for the third line, that the maximum number of appointments per day is, in this case, we can do a little bit of arithmetic, final appointment time minus start of day plus 1. Once that's calculated and assigned to max appointments per day for the first time, then it never changes after that. Right? So static means that a variable or method that's declared static is associated with the class not the instances of the class. And the final means that you're declaring a constant. Okay? So we've got these public things that are visible outside. Now, normally, we would make sure that our variables are declared private. Most of the time, we want variables associated with an object to be only modifiable by methods within that object. In this case, because they can't be modified anymore, they're constants, they're okay to be public, because nothing else can change them. But these ones, these are private variables that are now, they're instance variables, not class variables. Each instance of the day will have its own copy of day number, and this thing here is an array containing the appointments for the day. Right? Okay. Have you come across the keyword this before? Sometimes you want an object to be able to refer to itself. Right? So you can refer to other objects by the variable name representing the object, but sometimes the object wants to talk about itself. So this keyword represents this object. So it's saying that if I want to initialize day, I create a new day instance with a day number. As it happens in this case, the name that I've given to the parameter for the constructor is the same as the instance variable up there, day number. So how do I distinguish between the two? Here I'm saying that I'm going to initialize the day number belonging to this object with the day number that's the parameter passed to the method. All right, so is that too confusing? Yep. Yeah, if you wanted to, you just give them different names. But you will need to use this in some cases. So this is just illustrating one use of it. Right? There will be cases where you need to refer to, the object needs to refer to itself. Sometimes you need to pass yourself, if you like, to another method in another class. What does this line do? This one. It's the second line of the constructor. What does it do? A what? It does not create a new appointment. It does not make a slot. It makes the array of slots. Okay, so this is creating a new, whenever you see the square brackets like that, you're creating an array. So this is a fixed length array, not an array list. A fixed length array of length max appointments per day. And the type of the objects that can go into the array are of type appointment. Okay? So it's making an array of appointment slots, and it's this big. Okay? Now, it's important to note that there are no appointments in there yet. That when we start, that is an empty array. It's an array full of null pointers. Okay? If we've got time, or quickly. If we inspect that object, we've initialized it to have the day number 200, and appointments, if you double click on that, you see that we've got an array, and it's the right length to contain the number of hours in the day. But initially, all the slots are null. And as we add appointments, that'll get filled in. Okay, we'll carry on with this next time.